All right, so for this problem over here, you're given that the half-life of thorium-227 is 15.72 days. So we're going to label this out as our half-life. And it's asking you to solve for how many days. And anytime they ask for time like this, you know that you're solving for t. Okay? And you're being told here that 7/8 of a sample is decaying. Now, we talked about this in class, but this is really similar to number 6 off of the first half-life problem worksheet that you did a day ago. And when they tell you that 7/8 of a sample decays, it actually means that we have 1/8 of a sample that remains. Okay? And there's two ways that you guys could do this problem. The first way is a little bit easier, so I'll go ahead and set that up first. If you go back to this fractional quantity of 1/8 over here, if you took a quantity of 1 as our beginning number since it's a fraction, and if you half that, you would get 1/2. And then if you half that again, you would get 1/4. And if you half that again, you would take it all the way down to 1/8. And if I counted how many arrows I had here, I know that this is equivalent to 3 half-lives. Again, I just counted 1, 2, 3 different arrows, which meant that it broke down 3 times. Okay, so 3 half-lives that occurred. And because I know that the half-life of thorium is 15.72 days, the age or the time of my substance is just going to be my number of half-lives, 3, and I'm going to time or multiply it by the half-life itself. So we have number of half-lives is 3, and I know that the half-life is 15.72 days. And if you just go ahead and calculate that, oops, I did. So it's 3 times 15.72, and I would get 47.16 days as my answer here. Okay. Now, I also want to show you how to do this using the natural log equation, because if you had a quantity over here that wasn't something that was halfable like this, right, you would have to use the natural log equation. And because I'm dealing with a fractional quantity, I'm going to use the second equation that we had in our notes. So it's natural log of however much is remaining, which is 1/8 of our sample, and it's equal to our negative k times time. Okay, and remember that t is what you're going to be solving for, and the k I could solve for by just doing a simple calculation over here on this side. It's 0.693 divided by t1/2, so 0.693 divided by my half-life, which is 15.72. And you would wind up with 0.04408 here for your k constant. So we're going to go ahead and plug it all in. The natural log of 1/8 is equal to negative k 0.04408 times time. Okay. The natural log side, I'm going to go ahead and simplify off my calculator. It's natural log 1/8. And when I do that, I get a negative number. I get negative 2.079. Negative 0.04408 times t. And now to solve for time, we're going to divide both sides by the negative number, negative 0.04408. That cancels. And negative 2.079 divided by negative 0.04408. And you would get 47.16 days, which you could tell is the exact answer that we got up there. And we are done.